Welcome to this video on the topic of linear relationships. In this lesson, you'll learn how to deduce the equation that describes a straight line. By the end of this lesson, you'll be able to identify and determine the gradient of a line. You'll be able to determine the equation of a line using the gradient and a point. And finally, you'll be able to determine the equation of a line using 2 points. The equation of a line may be deduced in 3 steps. The first step being, you simply need to identify or determine the gradient of the line you're working with. So in other words, you might have to identify it as in m equals something. Next step, you need to either identify or calculate the y-intercept. In this case, it's going to be where you cross the y-axis. Then third step, you need to substitute the values that you've determined or calculated or identified in the previous 2 steps into the slope-intercept form equation. Slope-intercept form looking something like y equals mx plus c. And if you choose to go one step further, you can rearrange the slope-intercept form into general form, but that's not necessary. Sometimes you do because it's helpful, but you don't have to do that. Alright, let's have a look at an example of how this can be done. Example 1, we have a line defined by a point and the gradient shown over here. What we're going to do is we're going to deduce the equation that describes this straight line over here using the 4 steps over here. Now the first step is we need to either identify or determine the gradient that we're working with. In this instance, the gradient has been given to us in the form of m equals a half. So we are going to identify our gradient, and we can see in this instance it's m equals 1 over 2. So that was nice and simple. Alright, next step, we need to identify or calculate our y-intercept. Now the y-intercept is the point at which our line over here cuts or intersects our y-axis, so this part here. And what you can see is that on this particular example, this occurs at 0 and -2. So it's given to us, which is pretty nice. So what that means is that our c in this instance is -2. So I'll just write c equals -2. Now third step, we put it all together. We get our m and our c and we substitute it into the SI form equation. To do this, what I'm going to do is I'm going to be a little bit verbose, and I'll write out y equals mx plus c. But I already know that my m is equal to a half and my c is equal to -2. Therefore, when I sub this in, I find that my equation is going to be a half x minus 2. And therefore, I have just deduced the equation that describes this line over here. So this is as far as I need to go. Now there are some instances where we need to go further than this. So what we can do is we can rearrange this form over here into something called general form. General form being in the form of ax plus by equals c, where a is always positive. Now to do this, what I simply need to do is just employ my rearranging skills. To begin this process, I simply write my equation out one more time. And what I find is that for general form, my x's always need to be on the left-hand side, and so do my y's. And my constants, so just my numbers, need to be on the right. So what I can see is that this is okay, this needs to go left, and this needs to stay on the right. Writing this out, I have half x, so that's got to go, so I'll take it from both sides just like that. This will yield -half x plus y is equal to -2. Now for general form, I don't like having fractions, so what I'll do is I'll remove this fraction by multiplying all terms in this equation by the denominator of the fraction here. In this case, 2. This will yield minus 4 on the right, 2y there, and minus x here. So I've got minus x plus 2y equals negative 4. And I need to remember, general form, it is highly discouraged to have a negative coefficient for the x. So what I can do is I can divide both sides by negative 1, or I can times it, it doesn't matter. It will have the same effect. Thus, I have 4 on the right, minus 2y on the left, and just positive x on the far left here. So general form is presented as x minus 2y equals 4. So this is my general form. Again, you don't have to go to general form. It just happens to be, there are some instances where general form will be more preferable over slope-intercept form. However, that will become more apparent when we arrive at those situations. Alright, for this example, we are presented with a line that is defined by a point, 0, 1, and a gradient m equals negative 6 over 7. What I'm going to do is I'm going to deduce the equation that describes this line using the minimal, so the least amount of working out possible. Alright, let's go for it. For this one, we have our gradient is equal to negative 6 over 7, and our y-intercept can be observed as being 1. The form for slope-intercept form is y equals mx plus c. So therefore, subbing this in, we're going to find that we have negative 6 over 7x, and then the y-intercept is 1. So this is our equation that describes this line shown over here. So nice and simple, it's not too hard. Now representing this in general form, should we wish to, we can go y equals negative 6 over 7x plus 1. I rearrange by moving the x to the left hand side. So if it's negative 6 over 7, I'll simply add 6 over 7x to both sides. This yields 6 over 7x plus y is equal to 1. And I don't like the fraction, so I multiply all terms in the equation by 7. Or in other words, I multiply both sides of the equation by 7. This will yield 6x plus 7y is all equal to 7. And here is my general form presented right here. So this has been an example of how we can deduce the equation of a line defined by a point and a gradient using the least amount of working out possible. So 1, 2, 3, 4, 5, 6, 7, 8, 9 lines. So not too bad. Alright, let's look at a more vexing problem. Observe, we have a line defined by 2 points, point A and point B. What we want to do is we want to deduce the equation that describes this line over here. Now, if we go back to our rules, what we find is that we can still follow the exact same rules. However, what we need to do is we no longer need to identify, but rather we need to determine and calculate. Now, our first step is to determine the gradient here. Now, by observation, we know that our gradient is equal to the rise over the run, or y2 take y1 over x2 take x1. Now, knowing which x's and which y values to use, what I always recommend is just copy down the points that you're given. So point A is -2, -2, and point B is 2 and -1. I'm then going to label this as x1, y1, x2, y2. And what this will do is it will make me, I guess you could describe it as less prone to making errors. Moving across, I know that my y2 is -1, my y1 is -2, so minus -2, and that's all over x2 is 2 take -2. Calculating this out, I can see that -1 minus -2 is -1 plus 2, all over 2 plus 2. So therefore I find that my gradient in this instance is going to be 1 over 4, or a quarter. Okay, next step, I need to calculate my y-intercept. Now this one's a little bit tricky. What we find is that we can calculate it by using our slope-intercept form shown here. So I write out y equals mx plus c. And what I can use this equation to do is to compare any point that lies upon this line over here. So what we're going to do is we're going to use either point A or B in reverse to calculate C, so our y-intercept, or what would be that. Now to do this, what I'm going to do is modify the formula, and I'll say that minus mx and minus mx, so we're going to take it from both sides. So my formula is going to become C equals y take mx. And in this instance here, I don't want to work with a general y or a general x, rather I'm going to work with y1, x1. Now what is my y1 and x1? Well, what I can do is I can go over to this part over here, and I can take my A, or I can take my B. In this instance, I'll take this guy here. And using this, what I'm going to do is I'm going to say that my C value here is equal to, let's take y2, and we'll go minus 1. Take my gradient, I've already discovered it to be a quarter, so I'll go 1 over 4. And then my x1 is going to be, we'll take the x2 here, which is, sorting this out, it's minus 1 take, and this will be 2 over 4, which is the same as saying a half. So therefore, what I'm going to find is that it will be 1.5. So C is equal to negative 1.5. Alright, I've got my gradient, I've got my y-intercept. Now all I need to do is plug it into my slope-intercept formula. So y equals mx plus c. I know my m is a quarter. X take 1.5. And thus I have discovered the equation, or I've deduced the equation that describes this line over here. And if you look really carefully, what you'll notice is that the slope of this line is indeed a quarter, because you can go 1, 2, 3, 4, then up 1, so 1 over 4. And what you'll notice is we're cutting the y-intercept, or we're cutting the y-axis at a roughly 1.5, so negative 1.5 there. So this is indeed going to be our solution. Now if we wanted to go one better, and go to general form, so this will be the final general form I do, we can say y equals a quarter, x take 1.5. My x's need to be on the left hand side, can't have them on the right, so I'll take quarter x on both sides. This will yield as shown. Multiply both sides by, let's go for negative 4 all in one go, so we can deal with this negative up here in one step. Doing this, I get positive x plus, or I should say minus 4y, and then 4 times 1 is 4, and then the half is 2, so this is going to be 6. And thus we deduce the general form of the equation that describes this, I guess you'd call it pink line over here. Alright, final example. A line suddenly appears. It is defined by the points A and B. A, negative 2, 1, and B, 2 and negative 4. Let's calculate the equation that describes this particular line. Now again, notice that we're dealing with 2 points. First thing we need to do is calculate our gradient. To do this, I'll write out my 2 points I'm working with. Now, in the previous example, I defined x1 and y1, x2 and y2 as a, b respectively. I'm going to demonstrate that the assignment of these points doesn't actually matter. We can use whatever we want. So if I say that this is going to be x1, then this has to be y1. So this will be x2, y2. The order of 1s and 2s don't matter. So long as your 1s are paired together and your 2s are paired together, this formula will work. Alright, calculating the gradient now. I know that my gradient is equal to y2 take y1 over x2 take x1. I'm going to sub in the values now. So my y2 is 1 take negative 4 all over negative 2 take 2. Alright, computing this. 1 plus or 1 take negative 4 is 1 plus 4. And negative 2 take negative 2, well, that's minus 4. So it becomes 5 over negative 4. Or you can rewrite it as negative 1.25. And I might actually move this negative upstairs. So just move the negative out front. That makes it easier to manage. Alright, next step, we need to calculate our y-intercept. In this instance here, if we go back, we can simply recall that the formula that we're working with is this guy over here, c equals y1 take mx1. So I can simply grab that formula and say c equals y1 take mx1, and then I simply pick what point I want to use. In this instance, I used the second one first, so I'll use the first one this time. Doesn't actually matter which one you use. If you use this, then use both the y and the x. If you use this, you use the x or the y and also the x. You just got to pick one. Doesn't matter. Alright, subbing these in, my y is 1. My m is negative 1.25. Use the decimal for this. And my x is negative 2. Alright, in fact, it might even be easier to use the decimal here. Sorry, the fraction. So let's take it back a step and we'll go negative 5 over 4. Alright, it'll become apparent why in 1 second. I have 1, and then notice I have 2, and I have 5 over 4. They're both negative, so they become positive, but the 2 and the 4, that's going to turn into 5 times 2 over 4. And what you might notice is that the 4 is actually equal to 2 multiplied by 2. So what we can do is play a game of keep and kill here, and we can kill the 2's off. So this is going to become 1 take 5 over 2. Now writing this as a fraction, the 1 is going to become 2 over 2 take 5 over 2. So the y-intercept in this instance is going to be negative 3 over 2. Alright. Now, subbing this in, we know that y equals mx plus c. So therefore, our slope-intercept form is going to be negative 5 over 4 x, and then our c is minus 3, and thus we have deduced the equation that describes this line, just like that. And as mentioned, I'm not going to do general form again because I think we get the picture from these 3 examples here. So in summary, what we had a look at in this lesson was how we can deduce the equation that describes a straight line. By now, you should be able to identify and determine the gradient of a line. You should be able to determine the equation of a line using a gradient and a point. And finally, you should be able to determine the equation of a line using 2 points. So a gradient and a point, a gradient and a point, 2 points, 2 points.